So, I'm Kassian Wren, and I'm here to talk about WebAssembly. I just changed my name, so that's why the name thing is kind of weird. Some of you may know me as Cassandra Perch. I changed my name when I got married, and I found out it was the same cost to change my whole name as it was to just change my last name, so I said F it. And so both my names are from Star Wars now, because yes. Anyway, that's not what you're here to hear about. Again, married recently. Those are all JavaScript robotics that you see in the wedding. That was a lot of fun. I am an IoT author and addict. I've actually written a couple books on Johnny 5, so that was really cool to see the Braille printer. That was like really inspirational to see such a really like good disruptive piece of technology come out there. So I am autistic, agender, and intersex, and I'll be happy to talk about those within the reason and within the code of conduct outside of this talk. So if you see me and you have a question, don't ask me anything you wouldn't ask a cishet white guy, but like you can ask me questions about like my pronouns and stuff and what it's like to be me within reason. I use they, them, their pronouns, so please respect that. And I'm interested in the future of the web, which is why I'm here to talk about WebAssembly, because I truly believe this is the future of the web. But what even is WebAssembly? I find it's better to start with what WebAssembly isn't in order to dive into what it is. So what WebAssembly isn't is just a programming language or instruction set. You can write WebAssembly, but it's like writing actual assembly. Like, yes, it's a good learning experience, but I would recommend you write in other languages and compile down to WebAssembly rather than strictly write WebAssembly. It's not the death of JS, probably. We'll go into it in a little bit. I get quoted on this a lot. I say it with all the love in the world, and please add that in the quote, with all the love in the world. JavaScript is the cockroach of programming languages. It's not gonna die. Please add with all the love in the world if you're gonna quote me on that. Because people are like, you must hate JavaScript because you compare it to a cockroach. No, with all the love in the world. Anyway, you cannot ignore WebAssembly until it goes away. This is not something that you can kind of just hide from, and it's not going to affect your day-to-day. WebAssembly is a huge leap forward for power in JavaScript engines, and you cannot just ignore it like Nick Offerman is trying to do. It is not an out-of-reach experimental feature that can't be used in the present. For the most part, it can be used. And it's not something you have to install or have your users install, and that's a huge difference from, say, Java applets, Flash applications. A lot of people ask me, like, what's the difference? That's the main difference, is it's built into the engine. It's built into the browser, so you don't have to install anything or have your users install anything. So what WebAssembly is a compilation target for other languages, allowing them to run in browsers and on the web. It's an augmentation of the abilities of web developers to create more robust and more capable browser and JavaScript-based applications. And it's a huge evolution of the capability of JavaScript developers to bring in modules from other languages to the web. It's also magic, not technically or literally, but just hang with me. You'll get why in a minute. But then the question is, why? Why would you want languages other than JavaScript on the web? It's going to kill JavaScript. This is, oh, panic, panic, panic. Let's take a walk through the history of the web to see why this is important and why it's not going to ruin the web or ruin JavaScript. So I call this ancient.png. These are my mad art skills. And you've got your browser and you've got your server. Your browser in the past, before Ajax, had HTML, CSS, and JavaScript. I.e., you could make fun things float around your cursor, or you could pop up alert windows and tell you couldn't use your browser anymore, or stuff like that. And you would click a link and it would return a page, and you would click a link and it would return a page, and everything was on the server. All of the logic, all the information was on the server. You just sent back HTML and then sometimes CSS and images. And then Ajax came out, and that changed the web, fundamentally changed how we think about programming for the web. Because instead of thinking about what happened on each page refresh, you've now got Ajax calls, so you can get pieces of information, you can get images, you can get all sorts of stuff. So the entire way we build on the web today is built on Ajax. We wouldn't have React or Backbone, any of the front-end frameworks that we have today without Ajax. And I truly believe we're about to take a step forward that in size is comparable to the scope of the jump we made with Ajax with WebAssembly. And you might think, all right, Kassian, this is, you might be exaggerating a little bit here. Stay with me. Let's take a deeper look into what WebAssembly is and what it can do. What do I mean when I say it's a compile target? So other languages or language transpilers need a way to be compiled into the WebAssembly instruction set in order to run in the browser. But before you worry about whether your favorite programming language has a WebAssembly target, it probably does. This is just a very small subset of the list of languages that support WebAssembly. C, C++, Rust, Go, TypeScript, PHP, Lua. A lot of these support WebAssembly, at least experimentally, and some of them support it very, very well. Rust and C and C++ are the most mature in their WebAssembly support, with Go being a close follow. TypeScript is about the same level as Go. Anyway, I could go on for hours about that. You write your code in the language of your choice, and then you compile it into WebAssembly for use in the browser. So that means we can run more than JavaScript in the browser. Whoa. Think of all the things you can't do with JavaScript that you want to do in the browser. You can do most of those things with WebAssembly. And the reason I say most of those things is because if I say all of those things, I'm going to go, well, actually, later. So most of those things, just to be safe. But why does this matter? Why is this so important? And why am I up here excitedly telling you about this? I used to give a series of talks about using the right tool for the job and avoiding fanaticism. This was in the days where front-end framework fights were very common, and people would say, no, the only right way is to do this with my framework, or my favorite framework, or my favorite tool, especially build systems. Who remembers grunt versus gulp? I never want to live through that again. Just use the right tool for the job. And with WebAssembly, we're able to do that. We're able to augment JS at its points where it's not super strong. We're able to reuse existing code in the browser and on the web, and we're able to create better, faster, stronger user experiences. When I say we're augmenting JavaScript at its not so strong points, I'm saying anything to do with types. Yes, yes, I know, TypeScript exists. I am aware. Don't have to tell me. But when you're talking about JavaScript, just regular JavaScript, types are something that can be very tricky. Math-based applications, both from a speed perspective and a precision perspective, JavaScript, like me, not great at math. It can do the math. Like, just give it enough time, and it can do the math. But like, not very quickly. Code that can be more performant with a multi-threaded approach. I'm aware web workers exists. You also don't have to tell me about that. But like, again, we're talking about also code reuse. And anything dealing with graphics, image processing, et cetera, those are things that JavaScript isn't great at. CSS is getting better at those, but that's kind of a weird combination. So reusing code bases from other languages is one of the strongest reasons to use WebAssembly today. No need to completely rewrite existing tested libraries. Who wants to rewrite a 15-year-old C library with tons of unit tests that has a strong contribution chart and tons of things in JavaScript? Who wants to rewrite that? Yeah, I usually get like one hand, somebody sarcastically going, but no, this crowd, no one wants to do it, me neither. One tricky bit is you need to beware compiled file sizes. This is true of any asset in your web application. Compiled WASM files can get rather big. It really depends on what language you're compiling from and what compiler you use. So a lot of compilers are getting smaller and smaller WASM files out of larger and larger code bases, which is great. But much like images, much like JavaScript files, you have to be careful of the size. You can tell most WASM compilers what functions you want to keep, and it'll discard everything else, and it dynamically links out for you, which is kind of nice. But again, it's kind of like with node modules. You have to be careful about those link dependencies and how big they make your WASM package. Just like you have to worry about the node modules and how long that makes your build. So if we're building better user experiences, we're allowing users to do more in the browser by making the browser more capable. This can be used to craft better offline experiences because WebAssembly works offline. You download the WASM code into your browser, and it runs in your browser. I'll show you when I do a demo later. You can turn off your Wi-Fi, and your WASM will still work in your browser just fine. And it makes faster, more capable web apps within reason. Of course, if you write non-performant code and then compile it in the WebAssembly, it's not going to be more performant than the JavaScript that's running alongside it. But within reason, we can create faster and more capable web applications. So what does the web look like with WebAssembly? Back to my magic art skills. we've got Ajax, we've got service workers, and we've got WebAssembly. You request a page, you return a page, you use WebAssembly to compute something, you use a service worker third-party module, and then you get Ajax, and the server goes, yeah, okay. And the server says, lol, okay, because it's probably not even a server at this point. It's a collection of serverless functions, probably, possibly. So what does a WebAssembly application look like? How much are we going to have to change to deal with WebAssembly? Like, how much are we going to have to deal with here? The basic parts of a WebAssembly application look like any other web application. The only difference is the addition of .wasm files. Currently, you bring your WebAssembly modules in through ES6 import syntax. Script tag is in the works, but currently you need to bring it in through the import syntax if you're working in the browser. Let's dive in a bit. Sorry about that. I have my first demo here, which is a Rust application. Okay, all right. Make sure this is. So I've got a Rust file here, and I've got a JavaScript file here. I'm going to open up the Rust real quick. So this, let me make that bigger. Code demos, they're great. All right, that's slightly bigger. So what we've got here, extern create wasm bind gen. So wasm bind gen is what allows Rust to compile down into wasm. And we're including the wasm bind gen prelude. Then we've got both of our functions marked with a hash bracket wasm bind gen, and that tells wasm bind gen that we want to keep these functions and we want them to be available in the JavaScript. The first function is extern, and public function alert, it passes in a string. So what this is doing is it's actually hooking into the JavaScript alert function. So this is the ability to call JavaScript's alert function from Rust. So the interoperability, you can kind of see it in there. The second function is called greet. You pass in a string, and it calls alert with format hello, comma, the name that you pass in. So what does this look like in JavaScript land? So we've got our, I need to rename that to wasm. Const.js should be wasm, and it's import wasm, hello wasm.js. JS then, so we're saying load the wasm, then js.greet. You could also use await JavaScript, then say js.greet if you wanted. So what does this look like in the browser? Let me refresh page. So you can see that there it says hello WebAssembly. In our JavaScript here, we've passed in the string WebAssembly, and so it calls the alert function with hello WebAssembly. So that alert box was created and called in Rust, and then went back to the JavaScript and called the alert function from the browser. So not only do you have the ability to run code that's not JavaScript in the browser, you have the ability to interact to have interoperability between JavaScript APIs and your WebAssembly code, which is pretty neat. All right, so let's dive in a bit bigger WebAssembly demo. That's neat and cool and nifty, but like, let's do something that like actually has a production use case or something like that. Who here has used Image Magick before? The CLI tool is everything you could possibly want with images. Who wants to rewrite that in JavaScript? Yeah, that's what I thought, me neither. So this demo uses Image Magick to edit images in the browser. It allows you to take a capture with your webcam and modify it, and it not only allows fast image manipulation, but reuse of a very useful library with minimal modification and no rewrites. The WASM wrapper for Image Magick, I think, was 40 lines of delta between that and the regular Image Magick. You just had to tell and script in which functions you wanted to allow into the WASM file. And yeah, so you can use Image Magick in your browser, which is pretty sweet. So let's take a look at how that works. Back to here, and close that, and oh yeah, there we go. And so magic.js is the wrapper for the WASM, so it basically just calls all of the WASM files. My actual application is here. So I'm bringing in WASM Image Magick, and essentially, a lot of this is basically turning Canvas into a array of bytes so that Image Magick can understand what it is. But essentially, we're going to have a series of buttons that will call rotate, grayscale, add contrast, remove contrast, and blur on a photo. And when you hit the button, it'll manipulate the image. So let's see what this looks like in the browser. So I always look silly in selfies, so I'm just going to like own it. Excuse me. It's not that dark up here. There we go. So I always look silly. So let's rotate right and rotate left. Okay, that's cool, Kassian. CSS can do that. All right, can CSS do that quickly? No. Can CSS, or well, not CSS, JavaScript. CSS actually can do a lot of these things, but it's much harder to complete, as I've found. Remove contrast, add contrast, and blur. That blur is what I'm especially proud of. Like, that took about less than a second. Now, to prove my point, I'm going to turn off my Wi-Fi, and I'm also going to turn off the web server that's running behind it so that I can prove that this is running completely in the browser without the need for an HTTP server. So this is completely offline. I am completely detached from the server. That's the power of WebAssembly. Being able to reuse a library that's already been out there that can do things that JavaScript can't or can do much faster in the browser setting. It's neat. All right, back to presentation. Okay, now you're thinking, all right, okay, cool. That's, okay, I've seen something that WebAssembly can do that JavaScript is not necessarily great at, and photo editing in the browser, neat. But can I use WebAssembly today? Yeah, 88% global saturation. The only situation I've seen that's very common is if you have to support IE 9 through 11. It is only in IE Edge. That's the only common situation. It is even in Android browsers, which, what? I was very surprised to see it was in the Android browser. So WebAssembly can run just about anywhere except IE 9 through 11. And I believe there's a Opera Mini, and there's a very common browser used in China that does not have it. So if you're supporting that kind of market, it may not work. So this changes the entire landscape of the web. Like, this is huge. This is the ability to run multiple languages on the web. This is the ability to really give some power to the browser on a level that Ajax gave us. Not only are we able to collect pieces of information from the server without having to refresh the entire page, we're able to collect pieces of code that formerly we'd have to send the information back, run the code on the server, and then send the information back to the browser. We can now run that code in the web. So let's talk about Node.js, because this is a Node conference. Wait, what about Node.js? You've been talking about the browser and the web, so like, how does this apply to Node.js? Native heckin' modules. Who here has had a build crash because of a native module? If your hand's not raised, you either aren't aware that it's crashed, or you're just not raising your hand, because most of us have had a native module crash a build in some form or another. The problem with native modules, disclaimer, I respect the heck out of the Node.js team. They are doing an impossible job, and they are doing a really good job at it. So like, do not take this as a slight on the Node.js team. They are amazing. Native modules, however, mean recompilation of native code on every machine. This means if your architecture doesn't support the native code, or the build decides to fail, you're left with no working library. That can be a huge problem. WebAssembly works without flags on Node greater than 8. So all currently supported long-term service versions of Node support WebAssembly without flags right out of the box. So let's do some math. Sorry, I'm JavaScript math. I'm kind of taking a second. So we've got WebAssembly, and we have native modules, and we've got Node, and it's got WebAssembly, and we do native modules are in C, which, okay, computing done. WebAssembly, precompiled to the WASM instruction set, no recompilation on each machine. You just pass WASM files back and forth, and they run wherever Node runs. Doesn't matter if you're on a Raspberry Pi 2, doesn't matter if you're on the newest MacBook, does not matter. WebAssembly doesn't care, as long as Node runs, WebAssembly runs. You can use native code wherever Node.js runs. The drawback is Node.js can't do everything through WebAssembly yet. We need what's called a remote something interface. I swear I practiced this like 60 times. A remote function interface to deal with OS level stuff, depending on the machine. RRI. I know it's RRI, but I can't remember what the second R stands for. Now, native modules must be recompiled in each system or rely on cached compiled code. The underlying native code must work on the system you want to run it on. If you've been watching the dialogue around ARM v6, you're kind of like, oh no. Native builds can take a bit and don't always go as planned. And the upside is native modules give you way more control than WASM right now. So the example I have here is called Magica. It's the Image Magick CLI and Node.js tool compiled down to WASM. Just to show you the installation step. Oh, turn my Wi-Fi back on. All right, cool. Magica. All right, that's Image Magick installed on my computer. Without having to use brew, without having to use any compilation, the Image Magick is now running on my machine. My demo, which I'll show you here, node demo. So I'm going to convert a JPEG into a PNG at scale of 50% from the command line, and it's going to be javascript.jpg. And then it's going to output the file and the content. All right, so I'm going to go in here. I'm going to go to the correct tab. And then I'm going to say image cat, javascript.jpg. So this is the original image. I still love JavaScript. Believe me, I still love JavaScript. I just thought this was really funny. So then I'm going to run my index.js. If I can type, which is saying something. It's going to take a second. All right, processed files. I'm going to check. All right, I've got a javascript.png, and I'm going to image cat it. Ta-da! Half scale. So that's Image Magick running without having to compile. It just stuck the WASM on my machine and ran through that. So instead of having to compile C all the way down, it's already precompiled in a binary, and that's why it took 2 seconds to install. Wow, I might actually like almost run over, and that's impressive. I've never done that before, so I'm going to speed this up a little bit. All right, so we've got Magica. WASM with some work can start replacing native modules. Like I mentioned, we need an RRI, a remote something interface, for OS interoperability. I truly believe there are 2 scenarios for this. One is that we have an RRI written in JavaScript, and then we wrap that JavaScript further around WASM, and then we have more control of WASM modules, and we start to replace native code that way. Or it's written in another language, and we really start to like leverage different languages with JavaScript and Node.js, which could cause some interesting deprecation of JavaScript. Like I said, it's not the death of JS, probably. There are people out there who want WebAssembly to replace JavaScript completely, and there are people out there who would rather it augment JavaScript. And depending on what side you're on, you're rooting for it to be the death of JS, or you're like, no, it's not, calm down. So it really depends. And it can already replace native modules in a decent number of cases. For instance, Image Magick. That runs everything Image Magick can run from my command line with no discernible difference to me in performance. And it's all because it's the same library. It's just Image Magick. It's just precompiled into WASM. WebAssembly and Serverless, this is what I do to keep the lights on. Our Cloudflare Workers platform uses V8 and supports WebAssembly. There will be a QR code at the end to sign up for the free tier if you're interested. We mostly support Rust and C and C++ due to package size. As I mentioned earlier, you have to be wary of package size, and we have a 1 megabyte upload limit, so it can be kind of tricky. But yeah, that's our documentation. I would do a demo here, but I'm running out of time, so I'm going to skip that. So the future of the web with WebAssembly. The short version is augmenting JavaScript with code from other languages and creating a robust multi-language web. The future is a bit of a question mark. As I mentioned, there are people who want to completely replace JavaScript with WebAssembly, and there are people who are on the augment JavaScript camp. Who's gonna win that tug of war? As I mentioned earlier, JavaScript's kind of a cockroach, so I'm kind of leaning towards the augment side is gonna win, but we'll see. The future's still just a bit of a question mark as a result. I have a small request. If you are a hiring manager, I would like you to hire someone who is different from you. Be it sexuality, be it gender identity, be it race, please do that. And before you tell me, Kassian, it's hard. It's hard to find people. You know what's harder? Being a minority in tech. So deal with it. Because I know it's hard to find people who are different from you when you're hiring. But you know what? It's harder to be one of those people. So just deal with it and suck it up and hire someone different from you, all right? Thank you. Thanks for listening in general. I am kas@cloudflare.com. I can be found everywhere as Node Botanist. If you're interested in Cloudflare workers, you can scan that QR code and it will take you to the free tier. You get 20 functions, 100,000 calls a day. It's kind of neat, and it runs on V8. And that is my talk, as my time is up. Leave that up.
Thanks, that was so much fun. And FFI.
FFI. Dang it.
I know, they look pretty much exactly the same. It's just like there's like, what, 1, 2 extra lines to make an F into an R. But
yeah. Either way, I had the concept, which is the remote interface.
Like, yeah, I think it's a really exciting time to be in JavaScript. Because like you said, I totally agree that I think this is like the next revolution. And like Ajax was back in the day. Like, have you had a chance to mess with any of the like OpenGL games that were ported into the browser?
Not with code, but I've played with them like I played them.
Yeah. Oh, same. I've never written a game. It's a totally different world.
Yes.
But it's amazing to see this like graphically intense game running at 60 FPS in the browser, and you're like, the browser can do that?
Can now.
So you kind of mentioned briefly about Cloudflare workers with WebAssembly. Like, do you see much uptick so far?
Sort of. It's mostly been internal. We have, like, for instance, a really cool WebAssembly application written in Rust that creates a JST of the JavaScript that it's fed and then spits it back out, so it makes JavaScript more performant using Rust, which is like really kind of mind-blowing to me. But yeah, that's an internal project that someone's been working on, and some people are doing image manipulation with WebAssembly because it tends to just be faster than doing it in JavaScript and easier than doing it with JavaScript.
Cool. All right. Thank you very much.
Thank you. And thank you all.